So, cross product. For cross product, you have to recall your idea of matrices. Your idea of what? 3 by 3 matrix. Now, do you recall that your 3 by 3 matrix was given in this form, right? Whereby you have your A, B, C. This was 1, 1, 1, 2. If we were doing, or let's just use number, okay. This is A, B, C, D, E, F, G, H, and then I. Then you remember when you are taking this particular animal, you're going to take out this particular column and take out this particular row. You try to reduce them to a 2 by 2 matrix. You recall that, right? Good. Now, similarly, when I want to work on this component here, I'm going to take out the entire row and then take out the entire column. And I'm going to factor out what is remaining, reducing them to 2 by 2. Then, if I have a 2 by 2 matrix, and I want to take the determinant, it's very simple. It's going to be what? A multiplied by this, then this multiplied by this. I'm going to subtract them. You recall that? We are all on the same page, right? So similarly, if you have to work on this vector over here, if I want to take the cross product of this vector, right? I'm going to replace them in matrix form. And the first row is going to be what? I, J, and K component, right? Then the second row, I'm going to fit in my data. So what is the component of I here? 1. What's the component of J? Minus 2. What is the component of K? Minus 2. Similarly, when I go to the other one, I have what? 2, minus 3, and what? And 1. Fantastic. You recall that we used to associate this symbol to each of the cofactors, right? So for the first one, if I want to work on the I component, right? I want to work on the I component. So I'm going to take out this place and take out this place. What is remaining? So I have minus 2, minus 3, and then 1. This was for which of the components? Which I component? Fantastic. Very good. For what? I component. Now, let's do for the J. For the J, I'm going to take out the sign, which is negative here. So for the J, I'm going to take out this entire row, then this entire column. So what will I be left with? 1, minus 2, then 2, and then 1. This was for what? The J component. Are we together? Fantastic. Now, I'm going to take out this and work on the K component. For the K component, I'm going to take out this column. I'm going to take out this row. So what am I left with? So I'm left with what? 1 minus 2, 3. We have 3 and then 2. This is for what? For the K component. Any question? No. This is actually very simple, right? So to do a 2 by 2 determinant, I will just go with minus 2 multiplied by 1 minus into what? Minus 2 multiplied by minus 3 over here. Are we together? This is for the I component. Minus. What do I have here? 1 multiplied by 1 minus what? Minus 2 multiplied by what? 2. Then I have plus. What do I have? 1 multiplied by what? This way. Minus 3 minus into what? So we have 2 multiplied by minus 2. Are we together? It's very simple. This multiplied by this from the left diagonal minus what? This. This multiplied by this, which is over here, minus this, which is over here. So what are you left with here? Minus 2 multiplied by 4, minus 2 multiplied by 1 is what? Is minus 2. Minus 2 multiplied by minus 3 is what? This will give me 6. Then I have negative outside, so I have minus 6. And this becomes my I component. Then I have 1 multiplied by 1 is 1. Minus 2 multiplied by 2 is what? Minus 4. Minus 4 multiplied by this negative outside is what? So I have 1 plus what? 4. This is for my J. Now similarly here, 1 multiplied by minus 3 is what? So here I have minus 3, right? What about here? 2 multiplied by minus 2 is minus what? 4. So minus and minus is positive, right? So I have minus 3 plus what? 4 of what? K. So I can finish this up. Minus 2 minus 6. So I have minus 8i. 1 plus 4. Minus 5j. Minus 3 plus 4. 1 plus k. And that becomes the cross product of these two vectors. How cool is this? Very fantastic. Are we together? Do you have any questions? Let me go by it again. I have two vectors. I want to take the cross product. I say you are going to represent them. You're going to represent them in what? The matrix form. You see this? This is it. You see this other one? This is it over here. The component is 2 minus 3 and 1. 2 minus 3 and 1. Are we together? Then the next thing I'm going to do is to reduce it to a 2 by 2 matrix. I just want to get the determinant, and that is the cross product. Remember, if I want to talk about this I component over here, I'm going to reduce it. I'm going to take out all the elements on the column of this I, and similarly take out all the elements on the row. So if I cover here and cover here, I'll be left with what? Minus 2, minus 2, minus 3, and 1, which is over here. Very simple. The same thing, I want to take out this J. I'm going to take out the entire column and the entire row. So I'm going to be left with 1, minus 2, 2, and then minus 1. Similarly, for the K component, which is here, I'm going to take out this guy and take out this guy. So I'm left with 1, minus 2, 2, and minus 3, which is here. So by so doing, it is now a 2 by 2 matrix, which is very simple. Multiply, starting from the upper diagonal left, multiply minus this other diagonal. 1 multiplied by 1, minus 2 multiplied by minus 2. Similarly, this is it. Minus 2 multiplied by minus 2, which is here. Then 1 multiplied by 3, which is here. Then the negative is also here. And that's how you evaluate. I don't think there is any question on this.